Welcome, my geometry friends, to our next video. We're going to talk today about constructions and rigid transformations, our first unit, and we're going to address perpendicular bisectors. We've been laying the groundwork for that. So today you'll need your notes, your ISN, something to write with, and we will get started. So our big idea today is to look at perpendicular bisectors, to define that term, learn about the theorem associated with perpendicular bisectors, and learn how to construct one. So think back in the past hour or days, a couple days, you have used a handheld compass and a straight edge. You've played and practiced drawing circles, drawing lines, and you should have used the GeoGebra digital applet that to draw circles and lines. So you should be familiar with both of those things. If you are not, you need to stop, go back and watch the first two videos and do that. So recently we went outside and we stood between two trees in front of Webster. And we did that to discover what a perpendicular bisector was. So let's recall that for just a second, in case you were not there and didn't get to do that. So our trees acted as endpoints of a line segment. And that is a really bad line I just drew. But imagine that's straight, and I drew a perfect little line segment there. And so each person that was outside with us was asked to find a place to stand that was exactly the same distance from each tree. So the first person, if they were smart, hopped in and they took the spot right between the two trees, because that's pretty easy to figure out. And then everybody else had to fill in. So we had people up here and here, and they were picking spots that were about the same distance from each, doing their best to estimate where that was from each tree. And we did that here, and you can see these line segments, or this distance from let's call that A, tree A, and tree B, from A to the person, and the person to B should be the same size. So what happened when we did that is we ended up creating a perpendicular bisector with people. So let's look at what that means. In your notes, you want to add this definition. Perpendicular bisector will be your heading or your term, and then you'll add the definition: a line through the midpoint of a segment that is perpendicular to that segment. So we've got three examples here, and only one of them is a perpendicular bisector. So let's start in reverse and look at the two that are not and why they are not perpendicular bisectors. Let's go to the far right. If we look at FG, and it's crossed by IJ, and you'll notice that we hit the check mark of perpendicular. IJ crosses FG at a right angle. That means it's perpendicular. So I'm going to write that there. Perpendicular means at a right angle. A right angle is 90 degrees. But you'll notice the other part of our definition is midpoint, through the midpoint. And this point H, that is not the midpoint. Midpoint means middle. And the midpoint would be over here somewhere. So this example is not a perpendicular bisector. So let me erase this real quick so we have some space. Erase. There it goes. Pretty good. Go back to my pen. And now let's look at the second example. So segment AB, and it's crossed by line ED. Again, this is not a perpendicular bisector. What we have happening is we've got the midpoint. C is in the middle. It's the midpoint. But ED is not perpendicular. So this is not a right angle. So you have to have both things happening for your perpendicular bisector to exist. It has to be both perpendicular and it has to be cutting the segment in half. So the first example, PQ, segment PQ, is being bisected by XY. We know that by these tick marks that show us that each of these segments, P to J and J to Q, are the same size. And notice the little square box there that tells us that that's a 90-degree angle that's perpendicular. So when you're looking at perpendicular bisectors, that's what you're looking for. Both pieces of the puzzle have to be there. So if you haven't gotten that definition of your notes, pause the video, get that written down. Draw the example to help you as you move forward. And then I will see you at the next slide. So we're also going to add to our notes the perpendicular bisector theorem. And that just tells us that if a point is on the perpendicular bisector of a segment, then it is equally distant from the endpoints of the segment. So in our example, A and B are our endpoints, and any of these points on this line, any place I draw a point, or these points that exist, E, F, G, H, each one of them is exactly the same distance from A as it is from B. So I want you to get that added to your notes, that definition, and draw that example. You might want to put the tick marks to remind you that what that equidistant means. It means that those segments are the same size. If you need to pause the video, do it, and then I will see you at the next slide. So now we're about done with this. What you're going to need to do before you're ready to take the mastery check on this lesson is you need to go to these two videos which are linked in Canvas. They're going to step-by-step take you through how to construct a perpendicular bisector by hand. That means on paper with a compass and a straight edge. And then the second video takes you on how to construct a perpendicular bisector digitally in GeoGebra. So you need to practice both of those. You can pause that video while you're practicing, rewind it, go back till you've got that mastered. You want to practice both ways until you are confident that you have that memorized and you can create a perpendicular bisector, one of those methods. So you need to practice both ways, decide which one you like best, you're most confident with, and then practice that one until you can do it without looking at the video or without any notes. Okay? And then you'll be ready to take the mastery check. So you're going to practice perpendicular bisector constructions till you're confident you can complete it from memory. You're going to review your notes and definitions of the perpendicular bisector. And then you'll be ready to take the mastery check. And come get one from me, and we'll get going.